What if a nearly 4,000-year-old mountain still holds the memory of a forgotten science? What if stone markers, aligned to the movements of the sun and moon, were precise enough to map the sky long before written astronomy existed? High atop a volcanic peak in North Macedonia lies a place called Tatachev Kamen, better known today as Kokino. For more than 1,000 years, these silent stones followed the rhythm of the heavens. Discovered only in 2001, Kokino raises a troubling question. How did a Bronze Age culture, without writing or metal instruments, achieve such exact celestial knowledge? And what else was encoded into this mountain before that knowledge was lost? Kokino is not a building, it is a landscape deliberately transformed. The rock itself, formed by ancient volcanic forces, became the instrument. Natural fissures, shaped by time and erosion, were selected and refined into precise observation markers. The core observatory covers around 5,000 square meters, but it belongs to a much larger archaeological complex spanning more than 30 hectares. Among its most striking features are several stone thrones carved into a lower platform. These were not symbolic seats, they are fixed observation points, aligned toward the eastern horizon. From here, an observer could watch the sky rise with exact consistency. Authority, ritual, and celestial knowledge merged in a single position, reinforced by light itself. Archaeological evidence shows Kokino was used continuously from the early Bronze Age, around the 19th century BC, until the Iron Age, ending roughly in the 7th century BC. That is over 12 centuries of uninterrupted use. Pottery fragments, ritual pits, and even molds for casting bronze objects have been found here. Yet there is no evidence of a settlement. Kokino was not a place to live. It was a place to gather, observe, and perform rituals tied to cosmic cycles. At its core, Kokino functioned as a calendar. For Bronze Age communities, timekeeping was survival. Planting, harvesting, and managing herds depended entirely on the seasons, and the seasons were governed by the sun. From the stone thrones, observers used fissures on a higher platform as solar markers. These alignments are exact. At the summer solstice, the first light of dawn passes through a specific carved notch on the horizon. The same precision appears at the winter solstice and the equinoxes. Imagine witnessing that moment. As the sun rose, light would pass through stone and strike the observer directly, confirming the turning of the year. This was not symbolic, it was measurement. It is believed that large fires may have been lit on the peak at key moments. Such signals would have been visible for over 30 kilometers, informing surrounding communities that a new season had begun. But Kokino's true sophistication lies in its treatment of the moon. The moon does not follow a simple path, its rising position changes over long cycles. At Kokino, 6 additional markers track the moon's extreme northern and southern positions, its maximum and minimum declination. These positions repeat only once every 19 years. The observers at Kokino clearly understood this. They created a calendar system in which some years contain 12 months and others 13, keeping lunar and solar cycles in balance. This is the same principle known as the Metonic cycle, later formalized by Babylonian and Greek astronomers more than a millennium after Kokino was built. Here, the mountain itself became a calculating device, knowledge preserved not in writing but through alignment, repetition, and memory. Kokino challenges how we define science. Without paper, without lenses, without instruments, these people built a permanent information system. The mountain became their archive. More than 100 ritual pits have been found across the site, filled with ceramic offerings. It is likely that deities connected to fertility and cosmic order were worshipped here. Science and belief were not separate. Understanding the sky meant understanding the divine. At Kokino, astronomy, ritual, and survival formed a single system. There was no divide between measurement and meaning. Even today, questions remain. In 2005, NASA included Kokino in a list of significant ancient observatories alongside sites like Stonehenge. Yet some scholars argue that in a fractured volcanic landscape, not every alignment can be intentional. Archaeoastronomy demands caution. But at Kokino, the strength lies in the combination of precise alignments, archaeological evidence, and long-term use. Chance alone cannot explain 12 centuries of consistency. Who these people were remains unknown. Their knowledge endured for generations, then, quietly, disappeared. By the 7th century BC, the sacred role of the mountain seems to have faded. The chain of transmission was broken. Kokino is not just a ruin. It is a functioning instrument, a record of patient observation and disciplined knowledge, carved into stone. It reminds us that sophisticated science did not begin with writing, It began with watching the sky, remembering patterns, and passing that knowledge forward. This mountain is a library that was never written, and it leaves us with one question: how much more knowledge, built into stone and memory, is still waiting to be rediscovered?